This is a third and final video for section Seqr B. In this video we're looking at sigma notation. Now sigma notation is a method by which sums of terms can be easily denoted. The capital Greek letter, which is called sigma, is used to represent the sum of. The subscript below the sigma gives the lower limit value, or where you're starting, and the superscript, which is above the sigma symbol, gives the upper limit, which is the finishing integer. The values increase from the lower limit L by 1 each time until you get that upper limit. So you can see this represented here. The sum of f of k from k is L up to u. So I plug in L to start with, so I get f of L. Then I add 1 to L, so I've got L plus 1, and I plug that in. So now I've got f of L plus 1. And I keep going until I reach the value of u. So let's look at some examples here. I've got the sum of k from k is 2 up to k is 7. So I start at 2, then I go to 3, then I go to 4, 5, 6, 7. Add those all up and I get 27. Next, I have to plug in from k is 1 up to k is 3. So I have negative 2 to the power of 1, then 1 squared, plus, now I plug in k is 2. Negative 2 all squared, 2 to the power of 2. Now I plug in 3, so I have negative 2 to the power of 3, 3 squared. Simplify that out, and I have negative 2 times 1, which is negative 2, plus negative 2 all squared is 4. 4 times 4 is 16. Moving along, negative 2 to the power of 3 is negative 8. 3 squared is 9. Negative 8 times 9 is negative 72. Okay, add that all up and I get negative 58. Next, sum of k is 10 up to 12 of log of 3k plus 1. I might work this underneath so I've got enough room. So I have log, first of all I've got k is 10. So 3 times 10 plus 1. Move along. Log. Now I'm at 11. So 3 times 11 plus 1. Always show this substitution step. Don't try and work it out as you go, because if you make a mistake, the person marking can't give you any marks because they can't see that you've done the right thing. 3 times 10 is 30 plus 1 is 31. Plus log 3 times 11 is 33, plus 1 is 34, plus log 3 times 12 is 36, plus 1 is 37. And you could plug that into your calculator and get an approximate answer if you wanted to. Next, it's given me 3, 7, 11, 15, 19, etc. And it's going, the sum of k is 1 up until 4 of a to the n. So if I plug in for k, and I have a feeling there's a typo here, that n there should actually be k, so remember that and note it in your textbook. So what I actually have is, or what it should be saying, is a sum of k equals 1 to 4 of a to the k. Okay, so that is a typo. So I've got a of 1 plus a of 2 plus a3 plus a4. So looking up in this sequence, A1 is 3, second term is 7, third term is 11, fourth term is 15. Add those all up and I get 36. Okay. Next, write the following sums using sigma notation. So I know I'm going to go from k equals 1, and I have 1, 2, 3, 4 terms. Okay, so here, if I look at this first fraction, I have 1 over 2. So if k was 1, that would have to be 2k on the bottom. So when k is 1, I get 1 over 2 times 1 is 2. That works. Move along to k is 2. 1 over 2 times 2 is 4. Next, 2 times 3 is 6. So that works. Next one, x cubed, x3, x to the 4, x to the 5. So here, it might make more sense to say, well, k is starting at 2 and I'm going to go up to 5. I actually have x as being my variable, and I want it to put the power of k. So that's x squared plus x cubed plus x to the 4 plus x to the 5. Just some rules here. If you just have the sum of a constant, then you're going to be coming up all the way up to n and just at n times c. If I have this constant c here, I can bring it out the front of the sigma. So I can just work out the sum of this and then multiply the end result by c. Next, I can split this up. If I've got the sum of from 1 to n of f of k plus g of k, I can split it up to be the sum of f of k plus the sum of g to k. The sum of the first n terms in a sequence, so a1, a2, a3, a4, is called a series, and that's denoted by s subscript n. Okay, so Sn is going to be a1 plus a2 plus a3 all the way up to an, which we can use sigma notation to represent. The sum of a of k from k is 1 up until n. So let's look at some examples here. We have for each sequence determine S1, S2, S3 and S4. So here is my sequence 3, 7, 11, 15, 19. So that's telling me that A1 is 3, A2 is 7, A3 is 11, A4 is 15. So if I wanted sum of the first terms, that's from k equals 1 up until 1 of AK. So that's simply a of 1, which is 3. Sum of the first two terms, so from k equals 1 up until 2 of a to the k, which is a1 plus a2, so 3 plus 7, which is 10. S3, sum of k equals 1 up until 3, a of k, so you've got a1 plus a2 plus a3, which is 3 plus 7 plus 11, which gives you 21. S4, sum of from k is 1 up until 4 of a to the k, so that's a1 plus a2 plus a3 plus a4, so the sum of the first four terms, so 3 plus 7 plus 11 plus 15, and that gives me 36. Okay, looking at the second one here, here's my sequence, so that's telling me that's A1, A2, etc. So sum of one term is going to be from k equals 1 to 1 of a of k, so that's simply 1. Sum of the first two terms is going to be from k equals 1 up until 2 of a of k, so I've got 1 plus a half. I'm going to work across the page, which you shouldn't do, but so I can fit it in. So that's 3 over 2. S3 is going to be up to 3 from k equals 1 of AK, so 1 plus a half plus a third, which gives me 11 over 6. S4 is k equals 1 up until 4 of a to the k. So remember, if you were doing these, you'd be working them down the page, just doing it so it fits on the screen. That gives you 25 over 12. Okay, what now? Practice time. Seqr B4 and Seqr B5 in your textbook, and make sure you check your answers.